Welcome to Problem Solving in STEM, Introduction and Example 1 by Conceptual Calculus. In this video, we will learn an approach to solving problems in STEM and see one example solved using that method. Our first example involves trigonometry. Later videos have examples involving interest rates, physics, and engineering applications. The same problem-solving method can be applied to each of these problems. The first step is to organize the given information. Write down the given facts, convert all quantities to a consistent system of units, and assign variable names to any quantities that are unknown or changing. Next, identify what you are trying to find and write that down. Sometimes a diagram is useful, depending on the problem. Then, gather known information that relates to the problem but is not given in the problem statement. It may help to have an equation that relates the quantities, such as F equals ma, or a physical constant, such as the acceleration due to gravity on the surface of Mars. Once you have your information organized and you know what you want to find, it is time to plan your solution process. Sometimes it helps to break a large problem up into smaller parts that you can attack one at a time. Sometimes it helps to use technology. After you have a plan, carry it out. Organize your work and label each part as you go along. This will help anyone who later reads your work, and it will probably help you as well. Once you have a result, check it. Did you find the thing you were supposed to find? Did you get reasonable units? Do your results agree with the given information? Do they make physical sense in the situation? I will never forget the algebra student whose solution to the classic coin collection problem said that the coin collection included negative 2.3 nickels. I've never seen a negative nickel, nor 3/10 of a nickel. Make sure your results are reasonable. Finally, state your results in terms of the question. The answer is not x equals 4. The answer is the coin collection contains 4 nickels. Here is an example. A tower stands on an island. A surveyor stands at point A and adjusts the transit to match the elevation of the base of the tower. Since the transit and the tower base have the same elevation, the line between them is horizontal. That makes it perpendicular to the vertical tower. This angle does not look like it is 90 degrees. That's because of the perspective in the illustration. The surveyor sights the top of the tower at an angle of elevation of 24 degrees. Then, the surveyor moves to point B and repeats the process, finding an angle of elevation of 18 degrees. Points A and B are 40 feet apart. How tall is the tower? First, we organize the given information, starting by writing down the facts. Points A and B and the tower base all have the same altitude, which means the line through those 3 points is horizontal. The angle of elevation to the top of the tower is 24 degrees at point A and 18 degrees at point B. Points A and B are 40 feet apart. We want all information in the same system of units. We already have that. The only units in this problem are feet and degrees. We need a variable name for any quantity that is unknown or changing. Nothing is changing in this problem, but several things are unknown. We want to know the height of the tower in feet. I'm going to call that h. It may also help to name some of the other distances. I'm going to call the distance from point A to the base of the tower x. Next, we make sure we know what we are trying to find. We want to know the height of the tower in feet. That means we want to find the value of h. The third step is to make a diagram if one is helpful. In this problem, it is very helpful. My diagram is taken from the problem statement and the accompanying illustration. I'm running out of space here, so I'm going to delete the statement of facts. The facts are all in the diagram now, so we aren't losing much. Now we assemble relevant known information. Do we know anything about angles and triangles? We're likely to need some trigonometry here. Either recall or look up the definitions of the basic trig functions. If angle theta is in a right triangle, then the sine of theta is the opposite side of the triangle divided by the hypotenuse. The cosine of theta is the adjacent side over the hypotenuse, and the tangent of theta is the opposite side over the adjacent side. We have all the information we need to plan our solution process. Our trigonometric functions work in right triangles, so we want to focus attention on the right triangles. There are two of them. We will consider them one at a time. We should also decide what technology we want to use. It would help to have a calculator that will evaluate trig functions. I don't think we need anything more complicated than that. Now, we are ready to carry out the plan and solve the problem. As we do that, we need to make sure our work is well organized and clearly labeled so that someone later could read and make sense of it, and also so that we don't lose track of what we are doing while we are doing it. First, let's look at the larger right triangle highlighted in blue here. We want to know about the height, and we have information about the horizontal side. We don't have information about the hypotenuse, and we aren't really interested in finding out what it is. So we choose a trig function that does not involve the hypotenuse. That means we want the tangent function. The tangent of the angle is the opposite side over the adjacent side. So the tangent of 18 degrees is h over the sum x plus 40. We can multiply both sides by the denominator and then distribute the tangent to neaten this up a bit. Now we look at the smaller right triangle. We aren't really interested in the hypotenuse, so we use the tangent function. The tangent of 24 degrees is the opposite side, which is h, over the adjacent side, which is x. Now we have two equations in the two variables x and h. To solve these equations, we're going to need a bit of workspace. Since h equals x tangent 18 degrees plus 40 tangent 18 degrees, and h also equals x tangent 24 degrees, those two quantities must be equal to each other. We subtract x tangent 18 degrees from both sides to get all quantities involving x on the same side of the equal sign. That allows us to factor out the x. Dividing by the difference of the two tangents leaves x alone on one side. So we know that x is equal to 40 tangent 18 divided by the quantity tangent 24 minus tangent 18. Making sure the calculator is in degree mode, we get 108.03. The tangents are unitless and the 40 was in feet, so our result is in feet. Now we know x. But sadly, that is not what we were looking for. We were trying to find the height of the tower in feet, which is h. We recall that h equals x times the tangent of 24 degrees, so we get h equals 48.1 feet. Now we think about that. First, we want to make sure the result we found is what we were trying to find. We were trying to find the value of h in feet. That is what we did find, so that's good. We came up with a number of feet, so our units are good. Is our value of h about the right size to be reasonable here? If we estimate the height of a building at 10 feet per story, then this tower is about 5 stories tall. That's reasonable. Finally, we state the result in terms of the question. We were asked how tall the tower is, so that's the question we answer. We had two significant figures on our given information, so we round our result to two significant figures and say that the tower is 48 feet tall. That's the end of this example. For other examples using this method to solve problems, please see later videos in this series. Thank you for watching Problem Solving in STEM, Introduction and Example 1 by Conceptual Calculus.